Hello everyone. Today I, Vibhu, is going to explain you the Module 1 Introduction to Networking in an easy and effective manner. First of all, we are going to talk about what is Internet. Internet is a network of networks that connects billions of connected devices with billions of users to facilitate all different types of online services that we use on daily basis. We all know what is internet and we use it on a daily basis, but most of all lack the basic technical definition of the term internet. That's why I have explained just the basic technical definition that internet is a network of networks. And these all interconnected devices are called end systems or hosts. They are connected to each other via network devices such as routers and switches. We can see that there are different routers and switches used in the Wi-Fi modules. So what does a computer network basically means? Computer network is a network which is a set of nodes connected by communication links which are both wired and wireless. We have seen like different computers that connect to each other. They are also called the end systems. A node can be computer, printer, or any other device that is capable of sending or receiving data generated by other nodes in the network. Like we can see that computers and printers communicate with each other, or the mobile phones, PCs, tablets through Bluetooth or any other wired medium. We are going to understand about the two different and the basic types of networks. That is, the first is access networks. An access network is a type of network which physically connects an end system to the immediate router on a path from the end system to any other distant end system. The examples of some access networks are home network, enterprise network, and mobile network. The second type of the network is core networks. A core network basically connects different access networks. It consists of a complicated looking network of interconnected routers. The data is generally broken into smaller chunks of data known as packets. The examples of core networks is global ISP, content provider network, and data center network. So there are two methods by which we can transfer the data. These are circuit switching and packet switching. Circuit switching in this case is a slightly traditional method, and now it's not being used in the current world. Whereas the packet switching is more of a better and reformed version of circuit switching. In circuit switching, there is a physical path between source and destination, whereas in packet switching, this is opposite and there is no physical path. In the circuit switching, all packets use the same path, whereas in packet switching, packets travel independently. The main disadvantage of the circuit switching is that it reserves the entire bandwidth in advance, and in the packet switching, it does not reserve any bandwidths, and any number of packets can travel through a same path in the same duration of time. The in the circuit switching there is a lot of wastage of bandwidth, whereas in packet switching, we do not observe bandwidth wastage, or even if it takes place, quite it is not that much as compared to circuit switching. So in circuit switching, there is also no store and forward transmission, whereas in packet switching, it supports store and forward transmission. The time which is required to transmit a L-bit packet into a link with R bits capacity can be calculated by L by R. The time it takes for a packet to go from point A to point B on a given link is known as the packet transmission delay, since each link has a maximum capacity and speed. In packet switching, when a packet arrives at a router, the router examines the address and searches for its forwarding table, using this destination address to find the appropriate outbound link. When the required outbound link is found, the router directs the packet to this outbound link. There are two types of packet switching methods, namely queuing and storing and forwarding. What is a layered architecture and what are the advantages of it? Basically, the degree of modularity is high in a layered architecture. What does modularity means? Modularity is the ability of a architecture to get divided into parts and then form a complete the thing as a whole. The second advantage is the divide and conquer strategy. This helps in breaking tasks into small pieces during the design phase. It ultimately helps in reducing the design's complexity. The third advantage is that it's easy to test and change, as we have discussed earlier, that its modularity level is high. So it is divided into smaller parts. Its each part can be independently researched and evaluated, and if any fault is found, it can be easily altered for good. So there are mainly two types of layered architectures for computer networks. The OSI model, which is a 7-layer model. The OSI reference model describes how data is sent and received over a network. This model breaks down data transmission over a series of 7 layers. Each layer has a responsibility to perform specific tasks concerning sending and receiving data. The second type of layered architecture is the TCP/IP model, which we will be going to discuss further. I will be giving a brief intro of TCP/IP. It is a 5-layer protocol with the transport layer responsible for reliable end-to-end communication, and the internet layer accountable for routing packets from the host to the host. At the transport layer, TCP provides a reliable byte stream service to applications. So this model has 5 layers, each responsible for a specific role. The first is the physical network layer. The physical network layer specifies the characteristics of the hardware to be used for the network. The second is the data link layer. The data link layer provides error control and framing, and it also identifies the network protocol type of the packet. The third layer from the top is the internet layer. This layer accepts and delivers packets for the network. The fourth layer from the bottom is the transport layer. It ensures that the packets are arriving in sequence and without any error. The last and the final layer is the application layer, which defines standard internet services and network applications that anyone can use. I'm also going to tell you about a basic term used in this OSI reference and the TCP/IP reference model. It's encapsulation. As the packet travels to the TCP/IP protocol stack, the protocols at each layer either add or remove fields from the basic header. When a protocol on the sending host adds data to the packet header, the process is called data encapsulation. As we have seen, that the application layer sends message like M, and when it reaches to the transport layer, it attaches its header HT to the message M that it received from the application layer. And further, when it reaches the internet layer, it attaches its internet layer header HI, and the whole message now will be having two headers of transport and internet layer both. Thank you. Here was the overall review, and I hope that it can help you in understanding the basic concepts related to Module 1.